Dear students, I welcome you all to a new session on numerical. We will start with the statement of the numerical. This statement goes like this. To 20-degree involute spur gear mesh externally and give a velocity ratio of 3. Module is 3 mm and the addendum is equal to 1.1 module. If the pinion rotates at 120 rpm, determine. There are parameters to be found. First one is minimum number of teeth on each wheel to avoid interference. The second one is number of pairs of teeth in contact. So this question appeared in the year BTU December 2006, May 2010. So twice this question has appeared. Now let's take a quick look of the statement of the numerical. It says there are two spur gears. The spur gears have 20-degree involute which are meshing externally and give a velocity ratio of 3. Module is given as 3 mm and addendum is 1.1 module. If the pinion rotates at 120 rpm, determine the number of teeth on each wheel to avoid interference. So interference is not required. For that, how many numbers of teeth are required? Second, number of pairs of teeth in contact. How many teeth are in contact? So these are the two parameters that we have to find. So we will resume the solution. Given data are we list out one by one. So the first parameter which is given is phi equal to 20 degree. After that there is gear, the velocity ratio G is given as 3, then module is given as 3 mm, then there is speed of rotation N1, I'll call it as N1, is 120 rpm. Addendum is given as 1.1 module, which is nothing but 1.1 into module is 3, so it becomes 3.3 mm. Then the value of addendum constant of Gale is addendum constant of Gale is 1.1. With these details, we shall now proceed towards the solution. Now, in some numerical, if the addendum constant of Gale is not given, then one can assume it equal to 1. In most of the cases, the value of the constant is limited to 1. In this, it is equal to the addendum. This is again purely an assumption which is not given in the statement of the problem. So we shall now proceed. First one is minimum number of teeth on each wheel to avoid interference. Is given by small t is equal to 2AW divided by G into 1 plus 1 by G into 1 by G plus 2 into sine square phi. This whole thing is under the square root, so I'll write it as raised to half minus 1. So I'll put this as flower bracket, this as flower bracket, and that will differentiate the two terms. Now the reason why I have written this is G is equal to capital T by T. So if T is equal to T by G, so the term what you see here 2AW, and this whole term is T and G is denominator, this G. So it is because of this reason why we are writing the minimum number of teeth on wheel as this equation. Now if I try to substitute the values, I'll get T is equal to 2 into 1.1 in the numerator divided by value of G is 3, so I'll write 3 here, 1 plus 1 by 3 into 1 by 3 plus 2 sine square 20, and this is raised to half minus 1. So I will have to take a calculator and check the solution. So I'll put square root in the beginning for this raised to half. So I'll take the terms which is under flower bracket. So I'll write it as 1 plus 3 inverse into 3 inverse plus 2 sine 20 square. So this is the value under the square root. Minus 1 is this, so I'll do minus 1, I'll get this. So there is 3 here, multiplied by 3 there is numerator 2 into 1.1 is 2.2, so it is 2.2 divided by answer is 16.47. So the value of t is 16.47. Since the number of teeth cannot be decimal, this has to be equated to the next number, which is 17. So the minimum number of teeth required for avoiding the interference is 17. So I'll write the minimum number of teeth on each wheel to avoid interference is 17. Now this is the value of small t, so we know that g is equal to t by t, so the minimum number of teeth on the gear to avoid minimum number of teeth on a gear to avoid interference and write it as t is equal to g into t because of this equation. So t is equal to g is 3, t is 17, 17 into 3 is 51, so 51 is the number of teeth on gear to avoid interference. Next is the second parameter, which is number of pairs of teeth in contact. So this is again given by length of arc of contact divided by PC, which is circular pitch. Now question is, do we know the value of length of arc of contact? And the answer is no, we do not know the value of length of arc of contact. So length of arc of contact is given by length of path of contact divided by cos phi. Do we know the value of length of path of contact? The answer is no. So the length of path of contact is given by equation length of path of contact is equal to RA square minus R square cos square phi, whole thing is in square root, plus RA square minus R square cos square phi, whole thing is under square root, minus R plus R sin phi. So this is the equation for length of path of contact. Now do we know the value of RA, R, small r, and the answer is no. So we will find the values first and then substitute and try to get the answer. First parameter is pitch circle, radius of gear R is m into t by 2. The value of m is 3, so 3 into number of teeth is 51, so 3 into 51 divided by 2, so we'll use calculator. So it is 3 into 51 divided by 2, so it is 76.5. Next is the addendum circle radius random circle radius of gear, which is Ra, given by R plus addendum of gear. This is 76.5 plus addendum of the gear is 3.3, which comes out to be 79.8 mm. The next one is pitch circle radius of, now here there was gear, pitch circle radius of gear, so here it is pitch circle radius of pinion. R is equal to m into t by 2, which is 3 into 17 by 2, which is 3 into 17 divided by 2 is 25.5 mm. Similarly, the addendum circle radius of pinion is small ra, given by R plus addendum of pinion. So this is equal to 25.5 plus addendum is 3.3, so it comes out to be 28.8 mm. Now I shall add all these details in the above equation. So the length of path of contact is equal to R square is, this is R square. R square is 79.8 square, so it is 79.8 square minus R square. R square is 76.5 square cos square 20 whole raised to half. Then there is plus RA. RA is 28.8 square minus R square is 25.5 here, so it is 25.5 square cos square 5, this is cos square 20 whole raised to half. Then there is minus R, so minus R is 76.5 plus small r is 25.5 into sine 20. So this is the full substitution of LPC in the equation. So by simplifying, we should be able to get the value of LPC. We'll take the help of a calculator. So it is 70. Push this whole thing up. So 79.8 square minus 76.5 square cos of 20 square is this much. Square root of answer is 34.8 646, 34.6464. Then the next term, 28.8 square minus 25.5 square cos 20 is this much. Square root of answer is 15.97, 15.976. I'll write it as 7 because it is 6, 9. Then there is 76.5 plus 25.5, and put bracket here, sine 20. It will show me syntax error if I don't put a bracket here in the beginning, so I put a bracket. So it is 34.8860. You can put the whole equation at a time, but as a beginners we'll try to write like this. As we gain experience in solving the problem, we'll put everything in one go. 34.6464 plus 15.9767 minus 34.8860 is 15.737. So LPC is 15.7371 mm. Now with the value of LPC, if I go back to the numerical, I can see that the value of LPC, this value is substituted here. So I'll substitute it as 15.7371 divided by cos of 20, which comes out to be answer divided by cos 20 is 16.747. Now this is the value of length of arc of contact. I will put the length of arc of contact here. It is 16.747 divided by PC is pi into m. M value is 3, so I'll write it as 16.747 divided by pi into 3. I'll take the help of calculator and try to find the answer. 16.747 divided by pi into 3 is 1.77. The next number is also 7. So the meaning of the value 1.77 is, this means, it means that there are alternatively one pair and two pair of teeth in contact, and on a time basis the average is 1.777. This is the conclusion from the numerical. So we have reached to the end of the numerical. The statement of the problem was to find minimum number of teeth on each wheel to avoid interference. That we found it as 51 and 17. The next part was to find the number of pairs of teeth in contact, for which we have the equation number of pair of teeth in contact is equal to length of arc of contact divided by PC, which is circular pitch, but we didn't know the length of arc of contact, so length of arc of contact is LPC divided by cos phi. We didn't know the value of LPC, so the value of LPC can be calculated by this equation. We found the parameters which are used for this, then we substituted the values of LPC. We got the answer as 15.7371 mm. This value was substituted in LPC divided by cos phi. We got 16.4747. This value was substituted in LAC and divided by PC, circular pitch is pi into m. This value comes out to be 1.77. So the conclusion is, on any time basis, the average number of pairs of teeth which are in contact is 1.777. I hope you have understood the solution of the problem. Thank you for watching the video.